Hello, Professor. Good morning. This is Suleiman Muhammad. So today I'm going to discuss about the code that I have used to run my project. As you can see on the screen, I have written this code in Java. And before we start our discussion, I will execute the course. So in the meantime, some of the test case might get executed and we can see the results. Okay. So from the start, yeah, I have described a class called coordinate where I have described 2 points, x coordinate and y. This is basically act as a position index on to my closest pair problem. And coming to the main class, as you can see in the screen, I have taken all the value as you have instructed given in the assignment. And I have used a random generator class basically to generate all the random values and to make sure that there is no duplicate values in my code. So what I did is I used the hash set to store these points, and hash set does not store any duplicate values. Only the allowed 10,000 values will be stored. So coming to the next point, uh, I've coming to the time. So how would I measure my time? So basically, I have used an inbuilt system function called current time millis. So I use this two times in my program. One before the start of my brute force and the divide and conquer algorithm, and the second after calling after the execution of my brute force and divide and conquer algorithm. So I have recorded this runtime into a start and end variables, and now this difference I have stored in the algorithm. So the process is executed for the times 10 times, and we have only calculated the average value at the end. Now going to the average calculations, let's go to the top and see how I structure my brute force. As you can see in the screen, I structured my brute force and divided algorithm as per the algorithm you have given in the class. This is the normal functionality and basically it depends on the index of the closest pair in the given array. Okay, now coming back to the executions. As I said earlier, the time is recorded as end minus start. So now how I make this average. I use a inbuilt array stream function to store average runtime as a double value, and I use the print statement to print the statements. And let us go to divide and conquer and perform the same actions. Now sequence to the same screen, and you can see I got the output. Here, the average time to calculate the brute force for 1000 iteration is 48.1 millisecond, and the average time to for the divide and conquer for the 1000 iteration 10,000 iteration is 14.3 milliseconds, and and so on. Yeah, and similarly for the other iteration as well. So I have used these values to compute the table and all the required test cases in the graph and report, and I have labeled the graph as well. Thank you.